This is a conversation with John Quain. He's a bioethicist and ethics fellow at the Icahn School of Medicine at Mount Sinai, where he works at the intersection of clinical ethics, emerging biotechnologies, and science communication. John also advises Manhattan Genomics, the Manhattan Project for Gene Editing, bringing a philosophic rigor to some of the controversial questions in reproductive genetics. We talk about the evolution of AI and its ethical risks, the future of germline editing, and the emerging technologies that are rapidly changing medicine. This is the Acc Podcast. Please enjoy. Hi, John. It's so great to meet you and have this conversation with you today. I'm really curious about your background. So you have spent, I think, 20 years covering science and technology topics for some very major publications, New York Times, CBS News. I'm really curious about when did that shift come for you that you wanted to start focusing and talking about issues in science specifically?
The way back when I was in graduate school in philosophy. And so that was what I was on that path, that academic path. And then I was covering technology a lot, as you said, for the New York Times. I was a contributing writer there for 17 years, wrote stories for Rolling Stone about cyber stalking back in the day when that was like people were just figuring out what this internet stuff was. The Esquire, I worked at CBS trying to explain to people what was happening with security and cybersecurity and privacy and those kinds of issues. And then a few years ago, I came back to the academic world and I started to work in the field of bioethics. So I took my degree in bioethics at NYU and then working on my dissertation and following up and working on the dissertation now, and started as a fellow at about a year and a half ago at the Icahn School of Medicine at Mount Sinai here in New York City. And so working in bioethics there at the hospital, the clinical aspects. So I've been combining the science, the philosophy, and the clinical side of it all combated together.
Yeah, so you were on an academic path. What drew you back into academia in a sense after a very long career in journalism? And was there, how did you go from cybersecurity to biology? Is there it seems like such an jarring transition, a fascinating one nonetheless.
I did cover biotech before too. So I did a few years, maybe 10 years ago, we did a lot and some extensive work in biotechnology and stuff and could see things that were starting to happen. And philosophy is great. I love arguing about minuscule conceptual analysis, but many of the things we talk about at this level, maybe 100 people care about really discuss those topics and it can get obscure. It's intellectually stimulating, but again, this is an area in ethics and bioethics where it was really making a difference. And decisions have to be made, for example, in a hospital every day about transplants and who gets a transplant and who should get this life-saving treatment and who should maybe not be worth or available for them. So all those issues are much more practical. And suddenly those philosophical and ethical issues become real life issues. And that's really what drew me to this. And the science in the technology world with AI, and we're just scratching the surface there. It hasn't even begun to be explored in serious ways, but it's changing so much. And so that every day there's something new, and every day you're learning something new, and every day you can see progress, and that's very exciting. And so being able to apply ethics to a field like that is really attractive.
Yeah, I certainly do agree that in an age of artificial intelligence, the changes that are happening in science and technology, the pace of it is just exponentially increasing. And I think that's what makes this field so fast paced and so exciting. And of course, that will bring up a lot of interesting ethical questions related to biology, related to gene editing and AI. How do we safely use it? Should these companies be releasing AGI to the public? And how do we do that safely? I'm sure these are all questions that you've thought about profusely throughout your career. And it's fascinating. Like, what do you think about most times these days? What is that question that you're still thinking about when you go to sleep at night? And is there one or is there many? What goes on in your brain day to day?
Well, it's interesting in the philosophy conferences the last couple of years, I was giving papers on biotech, basically genetic engineering was the focus of mine. But all the other conferences were about AI. If you put AI, like business, or if you start a company, you put AI in it, there's a lot of attention. The same thing was happening in academia. So there was a lot of talk about it, but it's very new, just the same way it's only been a few years that we've had CRISPR available and people developing tools. And every single day, somebody sees another feature of it, a different tool that can use that basic technique of CRISPR. And it's just advancing so rapidly. So we're just starting. And I feel the same way with AI. Look, large language models are nice, but they're baby steps. They're very crude things that we've been using for many years. And it's pretty obvious we'll only get to a certain level. Somebody, though, out there is developing something that is going to be that next generation of AI. And that sort of makes it exciting. And why we talk about these issues now before these things actually arrive.
Yeah, that's interesting. I'm curious about what you think is that next leap in AI, because you're right in the sense like these LLMs, they've become quite ubiquitous. I literally know like elementary schoolers who are using ChatGPT on a daily basis, and they ask them like, do you find yourself using ChatGPT more or searching things up on Google more? And they're like, Google, like I just put in ChatGPT, and I'm like, that's pretty crazy. Even Google, right? You have that Gemini summary at the top, but it's ubiquitous. But I'm really curious about what you think is like the next frontier in AI. I mean, we have these like frontier models in biology and like drug design and that are just continually evolving. There's companies out there like Future House that are working on AI researchers, right? And like how do we develop a full stack AI in science? And so I'm very curious about your thoughts on what is going to be that next leap. And maybe if you have any thoughts about what company or what group might be leading that transition or leading that next generation thinking.
I don't think that we know who that next company or next person is, what they're working on. There are great, again, coming into biotech and medicine. AI has some great applications in imaging, in recognizing pattern recognition. That was the basis very much for these models. NVIDIA's chips, that was the basis of those chips. How many polygons could it calculate and handle in how many milliseconds? That is the basis of all the AI that's being worked on now. So it's very effective in radiology. Mammographies now, standard practices to use a program like that, and it's very helpful. What the next thing, but again, it's context sensitive. Applying it to any context, to anything on the internet, that's when it gets tricky. That's why it hallucinates and makes mistakes, because it's really not fundamentally designed to do that. It doesn't matter how many neural networks you have running in parallel. It's just, but somebody is out there. Someone is going to come up with a really general intelligence, is the way some people refer to it. AI, I don't know what that model will be. Maybe there's a conference right now, somebody's delivering a paper, that's going to be the next wave, but I'm sure it will happen. I just don't know who will be or what it'll be exactly.
Yeah, it's interesting. I think people have their speculations, like at Harvard, at least the general bodies, the general, I wouldn't say consensus, but there's a large opinion that Google will basically lead AGI. I don't know if that's true or not. It's really all speculation, but it would be an interesting thought. You mentioned like medical AI. I kind of want to
Yeah.
touch on that point because I think there's a very robust ethical literature that surrounds that you probably can speak to very well. I'm really curious about, yes, of course, these models have become effective at imaging based diagnosis, but they're not always effective, right? There's a chance that the AI will get it wrong. And, who is being held accountable in that situation?
It's partly ultimately the attending physician, the doctor will be, but like many programs now, there's so much pressure on those physicians to use tools that are available. And if they don't, they're very well aware of, if I don't use this tool, then I might be held liable in a malpractice suit if something goes wrong. And this is still preliminary. There's a confirmation bias effect that happens with them. There's also, if you miss something and this program shows it up, then you see doctors overreact or might overprescribe, let's say, something. And then they swing back to the center after months of dealing with it. So it's interesting what kind of an influence it has on the physician's practice to begin with as well. Some of them are much like mammographies are a great example where they're starting to see perhaps we could see much more advanced warning of something with so much data that they're going through and so many times. But you're right. I mean, the danger is they'll have more false positives, and then that changes the patient's attitude, and they take things that may never have happened. It's tricky. It'll get better the more data that they have, but yeah, it's definitely tricky right now. But like I said, the pressure is to use many of these programs, and if they don't, then they can be held liable too. They're in a bind.
Yeah, I want to bring out some of that philosophy background here from you, but maybe if you can incite your personal opinion on who should hold moral responsibility, the clinician who trusts the model slash maybe is careless and doesn't double check their own the diagnosis, or is it the engineers who designed it? Is it the hospitals that are forcing the usage of these models to improve efficiency and things like that? Like, where is the best place where we can weight this accountability? And from that, how can we try and minimize these types of cases where we get these false positives and the clinicians are majorly held accountable for that? Do you agree that they should be? Is maybe the question that I'm trying to get at here, if that makes sense.
Yeah, so I mean, there's definitely in bioethics or in philosophy, there's just a base level. There's something called the inaction bias. That is, if I don't do anything and don't give you any treatment and something goes wrong, you're blameworthy. But if I do something as a doctor and things go wrong, I'm blamed
Right.
more for that. So you try to, that there's a precautionary principle, and sometimes that makes people hold back from actually doing more aggressive interventions that might have helped somebody. Be that as it may, when you're talking about, so who should be blamed or held morally responsible if an AI program makes a mistake or a misdiagnosis, I think the answer to that, and then there's a lot of literature from the legal side, from the ethics side, from the clinical side. But I think that one people might look at on a practical level is the way we handle vaccines currently in the United States. So there is a fund that's contributed to every vaccine that's sold or every shot that you get. There's a portion that goes into this fund, and that fund is for those cases in which somebody does have an adverse reaction to something. And those lawsuits can amount to millions and millions of dollars. So this fund is there basically to handle cases like that. Hopefully as few as they are and how efficient and vaccines and safe they've become, there's still that fund. Something like that model may be something that we start to think about, because many of these programs do have an upside. They're especially in medicine, I think in diagnosis and catching rare diseases, something that you haven't seen a patient you see your whole career. Some AI programs have been good at showing they can detect things like that. So I think taking that model might be a really practical way to approach that.
That makes a lot of sense. I kind of want to shift to another
Yes.
subtopic within AI still, because I was really interested. Like, you've raised this alarm on AI inventing fake science, basically,
Yes.
that AI is being used to write papers and generate data. And I am in science, and I have seen how ubiquitous AI has become in
Yeah.
pretty much any aspect of science, from experiment generation, ideation stage, all the way down to writing, figure generation. And so I'm curious about, what do you think is like the single most critical vulnerability in our current scientific validation process, like peer review, grant applications, that you think is actively being exploited? And what do you see like a practical fix, or is it too complicated?
That's a really difficult question, because when you're teaching students, and these are extremely bright students, it's not that they're
Right.
not capable, but yeah, I think we're all seeing that in academia. And we talk about it a lot, what to do. Some professors have even said, okay, you're bringing a pen and a pad of paper to class, and they're doing things like that. What are they called? The blue book approach. You have to
Interesting.
use those blue books. And even for me, look, I'm not sure my cursive handwriting is good enough anymore to handle an exam. But that's been one kind of solution to these kinds of issues, and at least in teaching. So then you come to the journal issue that you raised. I don't know, you probably seen some recent articles about not only are people generating like mounds of papers to submit to all these small little journals, and there are a lot, hundreds and hundreds of scientific journals. So they're cranking things out for that, but they're also doing things like letters to the editor. So there's a recent article about a professor who a researcher published an article, and then he received a letter from the editor that came from the journal. The habit is to then send it to the original author of the paper. And he was looking at this and he realized the letter writer had cited this other research that contradicted his research, except the only thing was that other research was by that very same person. He'd done it. He'd submitted that, and it wasn't like that at all. In fact, it confirmed. So apparently, they've now traced a lot of people that are using these to just generate letters to the editor because it's a quick way to get in a journal. And then it's like you're being published in that journal. People are cranking those out, and topics that may not even be familiar with. They just send the chatbot out to that. What you do about that, if you've ever peer reviewed anything, it's a thankless task. Maybe you get an honorarium, just a small fee, but really you're spending a lot of effort and time, whether it's an article or a letter or a book. Yeah, I think we just have to go with the peer review and the old fashioned way. But yeah, it's difficult. And there's just volumes of material be created. So that's the other problem.
Yeah, and I've actually seen it also from the other side. I'm part of a research group, and so we've recently submitted a research article for publication, and we think that it's speculation, but we think that the reviewer might have used AI or some chatbot to give us reviews. I think it's unfortunate that it's being treated as like an easy fix or like a way to not really have to do the work that's associated with all the hard parts of science. And I think that's one part of AI that I don't appreciate has come into use in science, but I think largely it's been a tremendous benefit for pretty much anyone working here. But yeah, so we've talked a lot about AI at this point, which is fantastic, but I'm not an AI specialist by any means. I'm a biologist. And so I want to talk about, I think, what is on a lot of people's minds right now, which is gene editing, germline editing. John, you are the lead bioethicist at Manhattan Genomics, and this is obviously a gene editing startup that's aiming to eliminate inherited diseases through heritable genome editing. And first of all, do you mind just talking a little bit about your role and what that looks like as the lead bioethicist for the company?
Sure. I've been working in the academic side and arguing for allowing us in a very limited way to conduct germline editing, which is basically editing either the gametes or an embryo before implantation to eliminate some mutation or correct a mutation in some of these heritable diseases. That's the idea. As opposed to somatic editing, which all the gene therapies that people see and are popularized today, and some of which have been astoundingly successful, sickle cell, all sorts of different diseases that people are going after. In somatic changes, that you have to treat the patient, that you have to transfuse them, it's a very painful process, which not everybody realizes for that patient, making tremendous headway, but that's the difference between those two treatments. And I was really interested in the germline aspect of it. In these kinds of cases in which we know already there's a monogenic, one single gene that triggers a really devastating disease. And when we know that, then it seems, okay, let's target that and fix it before basically the embryo starts to really divide, before you have a blastocyst, anything of that size. Try to fix it before that happens. And that way, there aren't these neonatal deaths and fatalities or these urgent situations where within a couple of years you must treat this child or they'll suffer these devastating consequences. So it also would take it out of that family's germline. So essentially it would cure it, and then that child that you have no longer has that mutation and no longer can pass it along to anybody. So they no longer could pass it along to their children. So they're basically safe in terms of that and producing. So the advantages, the benefits could be tremendous. And so I had been writing about that and the ethical reasons why you should allow that and under what circumstances you should allow that. And lo and behold, came this company, Manhattan Genomics, and I saw something written about them and I reached out to them right away. And I said, this is what I've been talking about for years. This would be great. So that's how that happened.
Yeah, that's fantastic. I feel like obviously bioethics, that field that has existed for a very long time, but it wasn't until this conversation of germline editing and even honestly somatic gene editing where I think it really popularized that field, at least from my perspective as a student. Like I genuinely only learned of bioethics, I think in high school when in my AP biology class they were talking about like these new concepts. CRISPR was discovered in 2013 and later implemented several years later. But yeah, I think it was that discovery and honestly this conversation that popularized or it made it mainstream in a sense. Maybe you have other opinions, but I think at least from my perspective, it seems like that. And one argument that I've heard, the bioethical argument against germline editing is that compared to somatic gene therapies, you are essentially changing. There are risks associated with both, but the impact of a potential negative risk, if something were to happen, it would affect not only the mother potentially, but also future generations. And I'm curious about if you have thought about that, if just what are your thoughts on that? And obviously it's the positive aspect of germline editing, but it also creates more risk, right?
It could potentially do that. Yes. And that's the concern, is that it will affect generations to come. You'll often hear the phrase permanent changes or generations to come. Another bioethicist used to use the term, if you edit the genome like that, it affects us all. That may sound like an exaggeration because you and I know that DNA mutates all the time, and it's the nature of DNA to change. It's not a static thing. So permanent is with scare quotes around it whenever you do anything like that, because there will be changes. It's just a natural thing in human DNA to do that. That is enunciated, though, the concern that many of them have, in that think of it as if to the risk value for a small child who has a terrible thing like Tay-Sachs or something like that, your treatments are going to be pretty extreme because how devastating that disease is. Just like you would treat a cancer patient, the toxicity of those drugs that you may try is way outside the margins for somebody who's just obese or who, has some other illness that's not as severe. In the same way, though, I don't think that the risk is as great when you're talking about these monogenic diseases. That's why it's important to limit them to just that single gene. Many other diseases and things like Alzheimer's and others, they're polygenic. They clearly have other genes involved. They have variable expressivity that's going to affect that particular gene, even when you think it's the only one. And those are much more complicated. We're not there yet. We're not even there yet in determining what the cause of them some. But in these narrow cases, and now we have these tools, the risk is a lot less. And we can also sequence, which is something even 8 years ago, 5 years ago, the level of sequencing now and the accuracy of completely sequencing to make sure you haven't made an off-target edit, which is another concern, is now there. These tools weren't available before. So again, all these things are coming along, and it's just making it that much safer. Every new tool, every new precise tool that people discover. So in terms of making those permanent changes, yes, it could potentially in that family's lineage, but also for the better. So they would never have to worry about something like Huntington's coming up again and again, or trying every level, trying to do pre-implantation diagnostics and IVF and selecting and looking for the right embryo that doesn't carry that mutation. this is a way to treat those and correct them from the start, really.
So it sounds like you are like arguing that the ethical calculus depends on the context. So like severe monogenic diseases, the risk of intervention might actually be lower than the risk of inaction. And that kind of ties back to what we were talking about earlier, right, with the physicians and that risk of inaction, like what the harm that can be done to these patients if you don't do anything. And to me, that feels like the strongest case in support for germline editing, in that if we continue to put up these barriers and say, no, you can't do research on this, then we're never going to get anything that's safe to use in humans. And we're never going to see the potential impacts of this technology if we continually say, no, it's not safe. We shouldn't do it. We shouldn't do it. Obviously, we need to have incremental steps, right? We shouldn't just germline edit a human right now. That would not be safe to do at this point. But there needs to be steps made in that direction so that potentially we can get there and see the benefits of this. There are arguments, though, that people have made. I've talked to a lot of people on this podcast who are accelerationists. They really are in favor of germline editing, and then people who are very cautious. I think one argument that has been made against germline editing, that caution type of argument, is that why should, to articulate this a little more clearly, one argument that has been made against it is that why are we discounting other modes of parenthood that don't involve having your own genetically related child? I was wondering if maybe you can speak to that, or if you've thought about that.
Sure. Some of that even comes from the antinatalist group. I don't know if it's not so prevalent anymore, but there was a time when it was a thing, which is why you shouldn't probably have children. You should adopt children. There are lots of children in need, given the limited resources on the planet, sustainability, climate change. There are a lot of reasons why one might argue for that ethically. And what you should really do is to adopt a child and not have this desire for your own genetically related child. And there's certainly some movement and a lot of that out there. Often you'll even see it in commentaries near the end of the article will be something, or these other options. And then they will bring up IVF, and they will bring up that you could have a surrogate. You could take another egg, or especially in the male side, a different donor. And that would be a way to avoid some of these diseases, because some are unavoidable. If it's in the mitochondrial DNA of the mother, that's just, you can't use that. So you've got to come up with some genetically engineered solution, or have a child that is not related to you that way. I think that's an option for many people. I think that's fine as an option, but I think as a ethical prescription to say that's the case across the board, that's the only way, ethical choice, that I think is too harsh. It's what we call, it's too demanding of criteria and ethical criteria. And I don't think the implication often is that couples who want to have a child that's genetically related to them are being selfish somehow, or being unethical somehow. And I don't think that's a correct way to approach that. I think it's a natural human part of our story for people to want that, and for couples who, it's often discounted, but I think the factor of love, and that you want to express that and have a child between those two people, I think that's a valid desire. And I don't think that's being somehow selfish. But so at any rate, that should be an option for people who discover, unfortunately, that they may both carry a gene that is going to result in a child that is going to suffer like that. And that ultimately is what we're trying to do, is eliminate suffering, which is the principle of beneficence in bioethics. And it's one of the 4 pillars. So you're trying to treat people and provide them this opportunity and this choice and reduce suffering. That would be the one thing. And the other concern that you brought up before is non-malevolence, not do no harm, basically, is the way people understand that. So that the concern is the risk is too great. So you're balancing that. But on the other hand, the autonomy issue of parental autonomy is the other thing in bioethics. People should be allowed to have children if they want to have children, and they have some autonomy. We allow them autonomy in many other respects to take a cancer treatment or not take a cancer treatment. That is up to the patient and up to that individual in the same way. It's balancing these principles and getting the right balance. And I think that you're right to do the research now. If you don't allow it, then what you regard as dangerous and immature science will always be dangerous and immature science because you're never going to get further. And the first appendectomy probably was pretty risky, but now it's an everyday occurrence.
Yeah, and I think I forgot to tag on this statement to that argument, which I think might have been important, but I think the argument was that, like, why are we spending our time, talent, and treasure on this problem versus other problems? Because there are other forms of having a child. Maybe you want to speak to that. Yeah,
I think that's a good concern. That the utilitarian point of view, like
exactly.
we could be spending this money to solve poverty and
Exactly.
lots of other things, all of which are good goals, and definitely the social determinants of health. Many bioethicists work in that area, and I've met some of them in the UK and some prominent people working in that area, which is a great thing to do. But it's a frustrating hill to climb all the time, using money to do some good work in these areas. This is not, people regard it as one and done, is one way of putting it. Look, if I get everybody with Huntington's and I'm able to edit that out and make it fairly inexpensive, and the more times we use that tool and the better we get, it'll be less and less expensive and more accessible. In theory, we're basically eliminating that disease and eliminating all the costs that go into the healthcare system in trying to help people that come down with these terrible diseases, and the families and the strain on those families. If you're looking for outcomes from a utilitarian point of view, potentially this is a much better outcome than using those funds for other ways. But there's also what I like to call the iPhone argument, which I'm sure you've heard a million times, which is it's really expensive now, but look, we keep making iPhones. My first cell phone, I don't even want to tell you how much my first cell phone is. And now you can get for a few dollars, not the state of the art, but it's pretty accessible. So that's the goal too.
Yeah, absolutely. So we've talked a lot about, I think, two realms, right? AI and germline editing. And obviously, bioethics, this field is not, there's tons more topics that people do research on in this field. Like, I think these two might be the most mainstream, but there's certainly many others that you have talked about and that I've had conversations with others about. But I'm really curious, like, what do you think is going to be like the next hot button issue in this space? Like germline editing, I would say is probably today's problem, but from your vantage point, are there any emerging technologies in the lab, like synthetic embryos, like BCIs, maybe even it's AI, a newer version of it that you think that we're the most unprepared to handle potentially? Or yeah, what's next?
What's next? Definitely genetic engineering in different forms, whether it's somatic editing and treating individual patients, or germline editing, where the idea is to come up with the basic tools to make it incredibly safe. And so that means prime edits that are specific tools for one specific allele. It may just come down to that. And that is a whole area which is going to constantly come up. There are a lot of end of life decisions that are related to technology that people don't really realize, but it was only in the 50s or so that ventilators were developed. And now, as we saw after the pandemic too, where that was really in the public eye about the use of them, who gets to use them, who doesn't, and how long people should be on ventilators. Those end of life decisions have really become more acute, and there are developments like using ECMO machines. Watching something like that go from not being used to, oh, your heart and lungs aren't working? No problem. I'll just plug you into this machine. That just presents all these new ethical questions in either whether it's intensive care or in ER, and which patients get them and how long they're on, and whether they want treatment like that and interventions like that. So that's what I find fascinating, these new interventions that come along. and change the landscape of practice of medicine, and then bring along these ethical issues as well. I'm not sure what that new technology will be in this sense, because I the first time I saw ECMO was pretty remarkable. People are working on portable ones. Oh, yeah, you can imagine extending somebody's life long enough so that they could receive a transplant, or long enough that they could receive some other treatment. I was talking with a transplant surgeon earlier this week, and they want to do perfusions with liver, that people are working on that so that you can do it now with the heart. I'm sure you've seen the heart in a box, where the transplant, they're keeping it alive so that they can have that many more hours to get it to a patient in need, which they've done a pretty good job of doing that with hearts. Livers have not been as successful, but they are working on it, which would mean that whole system of the way we have a transplant list and patients get sorted and what part of the country they're in. If you could keep that liver still viable, again, amazing. It does seem a little science fiction like when you actually see it in operation, but wow, somebody who before we couldn't reach, or a liver we couldn't save because we couldn't get it to somebody in time. And a lot of livers and transplantation, just we can't use them. We couldn't get to a patient in time. So those technologies, I think, are coming along. You'll see a lot more of that.
Yeah, absolutely. I feel like all of medicine, all throughout history has just been this question of like, how do we extend life? And antibiotics extended life tremendously. Once we solved most, if not all, infectious disease, that was a huge step. And now we're beginning to see remnants of like cancer therapeutics. We see all types of modern medicine that's allowing people to live way, way later than they previously could. And these technologies that they're mentioning that could even extend the time span in which a person can be in a vegetative state, so to speak, and get those organs that they need is incredible. And then obviously there's a pretty robust like longevity movement that's happening in science where there's researchers trying to investigate how can we extend the human lifespan. And I'm sure that will raise tons more ethical questions. That was what came to my mind when I was thinking like, what will be if how far out is this field? Will we actually begin to see anti-aging drugs or not? Personally, I don't know, but I think that definitely will raise a lot of ethical questions that will continue to expand the field. But yeah, looks like we're coming up at the end of the time here. Thank you so much, John, for joining me. It was a
Absolutely.
pleasure to have this conversation with you.
It's fun to discuss them with other people too, and have a couple of
Yeah,
people, because we could talk about advanced directives and things like that people have, and the technology affects those. Even though I say I don't want, patient says I don't want to be hooked up to these machines, they're awful, and I don't want my life extended that way. 15 years later, when they're actually
right.
in that situation, the technology is different. And then the clinicians are thinking, they didn't even know about this. They're going to
Right.
be on the machine for
Interesting.
3 days. Did they mean they didn't want to be on the machine for 3 days? That I could save their life? It, that's how rapidly things are changing. And that's where it
Right.
makes a difference in those kinds of decisions too.